I'm going to prove that the limit of a to the power of n over n factorial is equal to 0 as n approaches infinity, where n is positive integer. So first of all, when a is equal to 0, right? 0 over n factorial is obviously tending towards 0. So we're going to assume that a does not equal to 0, right? So in this case, I want to look at, first of all, I'm going to let n be big enough so that I have some k where not only n is larger than k, but also k in this case is equal to, because a could be positive or negative in this case. I'm going to use the absolute value of a, right? So this is definitely a positive number. I'm going to take the floor of this positive number. Could be some decimal number, doesn't matter. Take the floor, this becomes an integer, positive integer. I'm going to plus 1. Right? So I'm going to choose a large enough positive integer, k, that is equal to this value. Then I'm going to let n be big enough, right? Larger than k, because in the end, n will tend towards infinity. So in this case, I can rewrite my original expression, a to the power of n over n factorial can be now written as, first of all, I want to prove that given any epsilon larger than 0, there exists a capital N as long as little n is larger than capital N, then the absolute value of a to the power of n over n factorial minus 0 can be less than epsilon. This is what I want to prove, right? To prove that the limit is equal to 0. Now, in fact, the left-hand side can be written as, because this quantity minus 0 absolute value is equal to absolute value of just this quantity. Then I can rewrite it, the absolute value, first of all, the absolute value of a raised to the power of n over n factorial now is in fact equal to this left-hand side. Can I prove it to be less than epsilon? First of all, it's impossible for me to solve the inequality just right away. But what I can do is I can first of all rewrite it into a absolute value times all the way to absolute value of a. How many of them? There are exactly k. K of them. Then on the bottom I have k times k minus 1 all the way down to 1. It's a k factorial. So k for a is fixed, right? K is also fixed. Therefore, this part is also fixed. Let's denote it as m that's larger than 0. Now, I still have something in the front, right? So first of all, I have a, absolute value of a, over n. Now I have times absolute value of a times all the way to absolute value of a. This time here I have exactly n minus k minus 1, many of them. Because I've already split one of the absolute value of a down in here. So therefore, all in all, I still have exactly n, many of them. Right, down the bottom, I still have n times n minus 1. All the way down to k plus 1. Now, I just have to look at absolute value of a over n minus 1, so on and so forth, until absolute value of a over k plus 1. Remember, k is large enough, larger than this value. Now, when I look at absolute value of a over k plus 1, remember, both the top and bottom are larger than 0, right? Then I claim it is less than 0. The reason is because k is large enough, right? K is equal to the floor of the absolute value of a plus 1. Remember, what's the meaning of floor? For example, if I have some absolute value of some number, right? That's some positive number, that is, for example, 2.3. Right? If I take the take the floor, that is the integer part, that is 2. Right? Then I still have the plus 1, that is 2 plus 1 equals 3. Right? So in this case, the absolute value of a is equal to 2.3, for example. And k, in this case, is equal to 3, right? 2 plus 1. K is equal to 3. So in other words, 3 is definitely larger than 2.3. In other words, generally speaking, k is definitely larger than absolute value of a. And here, I have k plus 1 is even larger than absolute value of a, of course. So therefore, the smaller number over a bigger number, both being positive, of course, smaller than 1. So on and so forth. In general, absolute value of a over n minus 1. Right? Because like I said, n is large enough, way larger than k. Right? Because in the end, n will tend toward infinity. So this is perfectly fine. So again, less than 1, larger than 0 for the same reason. Now, if I replace absolute value of a over n minus 1, absolute value of a over n minus 2, and absolute value of a over k plus 1 with 1s, right? So 1 times 1 times 1 times 1 times 1. So this part is replaced with 1. So whole thing is larger. I've loosened it. I've loosened it. So this is in fact loosened. But I still have absolute value of a over n. This still remains. And I still have this part, like I said, is a positive constant. Therefore, I have, first of all, m times absolute value of a over little n, right? Because, so this one, this one, this one, this one, all replaced with 1s, right? So therefore, this part becomes 1, becomes larger, and absolute value of a over n still remains, and also this part denoted as capital M still remains. So this is indeed enlarged. Therefore, constant, except for n, right? So I just need to let this be less than epsilon. Then I can solve for n. Now, n is larger than m times absolute value of a over epsilon. All right, so as long as n is large enough, how large? Larger than this, and also larger than k. All right, is it achievable? Yes, because like I said, k is already fixed. And n, of course, minimum requirement is that n has to be larger than this value. And of course, at the same time, larger than that value. So all in all, I've really found my capital N that is the maximum of absolute value of A, floor, plus 1. That is my K, right? So, and also M times absolute value of A over epsilon, right? So epsilon is any given fixed positive. M is also fixed, I've shown. Absolute value of A is also fixed, right? Absolute value of A, floor, plus 1 is also a fixed positive integer. Therefore, as long as I can take the larger one out of those two, first of all, this is also a floor, right? So this is also a positive integer. We can take the larger positive integer out of those two positive integers to be my capital N. So as long as little n is larger than this capital N, then this inequality is true. Now, this inequality means, like I said, this is in fact equivalent to the left-hand side, right? After I get rid of 0 and take the absolute value inside, right? This is actually the left-hand side. Is really proven to be less than epsilon, right? I've really shown that it can be less than epsilon as long as we choose the capital N to be this value, right? As long as n is large enough, then this inequality is true. Now, I'm going to use this result in a future video to prove that pi is irrational. I will be using this result in the final step of my future video where I will construct an integral. And during the last step, I will be using this result. Of course, there are a number of different ways to prove this result. I'll make some videos in the future to show that.